Okay, part 3. Number 10 is quite similar to number 9, and when you wrestle all of these percentages into grams and then moles, you'll find that the empirical formula is C2H4O. And then when you determine the empirical molar mass, you'll find that this is 44 grams. And then when you compare the empirical molar mass to the molecular molar mass, you see there's a 2-to-1 ratio there. And so in order to get the molecular formula, you multiply everything by 2. And so that means you have C4H8O2. All right, and there's your molecular formula. All right, next one, number 11. Okay, now let's see here. You've got a sample with a total mass of 10.64 grams. It's a lead compound, so we know it has lead, and it's analyzed and it's found to be made up of 9.65 grams of lead, 0.99 grams of oxygen. Determine the empirical formula. Okay, so for this, let's think for a second. We can simply take the number of grams of lead and go right to moles. So let's try that. So here's our calculation for lead. 9.65 grams of lead. So 9. Well, let me indicate what we're doing here. So moles equals 9.65 grams, and we divide that by the atomic mass of lead, which is, according to my table, 207.2 grams. And when you do that out, let me just double check. 9.65 divided by 207.2, I get 0.0466 moles. Okay, now for oxygen, let's do the same thing. So the moles equals, this time you're going to use 0.99 grams divided by 16 grams. And when you do that out, you will get 0.0619 moles. And that's for oxygen. All right, so if we start constructing our empirical formula, that's 0.0466, oxygen 0.0619. All right, not a very pretty empirical formula so far, so we know how to convert this to whole numbers. We divide both mole values by the smallest, 0.0466. And when we do that, we'll get Pb with a 1 and oxygen with 1.33. Okay, so that looks kind of odd, right? But this is a ratio that we talked about in the intro video. So the part 1 video, if you need to go back, take a look at that about midway through. When you get ratios that are, a number, a decimal, and then something around 0.33, then that is crying out for multiplication by 3. And when you do that, what you get is PB3, and when you multiply 1.33 by 3, you get 4. Okay, and so the molecular formula, the empirical formula is PB3O4. And we don't know whether that's the molecular formula or not because we don't have a molar mass value of the whole thing. Actually, technically, this is an ionic compound, and by definition, ionic compounds, when you have a chemical formula for an ionic compound, you're just being given the lowest whole number ratio. So there really is no such concept as a molecular formula for this one. And I would never try to trick you by asking for a molecular formula of an ionic compound. That's about as far as you can take it. Okay, just checking my time. All right, one more problem to go. Let's take a look. Let's see. You got 2.65 gram sample of a salmon colored powder, and it contains 0.7 grams of chromium, 0.65 of sulfur, 1.3 grams of oxygen. What's the molecular formula of this compound if the molar mass is this? Okay, so this one we can take all the way to a molecular formula. So we know we have 2.65 grams total. If you're thinking what I'm thinking, well, let me ask the question. The fact that they gave us the total mass of the sample, are we really going to use that? Do you think we'll need that at some point? And the answer is actually no. You don't really need that. It's nice to know, nice that they give you that, but the data that you're really going to make use of are the three mass values of the three different elements. All right. So step one, we need to take the mass and convert them to moles, and then once we have the moles, we can then construct the mole ratios from which we can derive an empirical formula. And from that, we'll be able to use the molar mass that was given us to get the molecular formula. Okay, so that's the chain, that's the sequence that we're going to need to work through. All right. First, chromium. So we have 0.7 grams, and when you divide that by the atomic mass of chromium, which is 52, you will get this many moles, 0.0135. And these are all moles. Okay. How about sulfur? All right, we've got 0.65 grams, and we divide that by the atomic mass of sulfur, which is 32.1. You will get 0.0202 moles. And then finally, oxygen. When you convert that to moles, you should get 0.0813 moles. All right, so let's start constructing the empirical formula. So that's CrSO. Now, I'm going to do a little shortcut here. Rather than writing each of the number of moles down here as subscripts, first let's just figure out which one of these is the smallest number. Okay, the chromium is the one that has the fewest, so we're going to divide all of them by 0.0135. And when we do that to chromium itself, that ratio is 1. When we divide 0.0202 by 0.0135, you'll get something very close to 1.5. And when you divide 0.0813 by 0.0135, you'll get something very close to 6. Okay? All right, everything's a whole number except for the sulfur subscript, which is 1.5, and we know what to do with subscripts that have a 0.5 decimal. We multiply them by 2, and that will give us Cr2S3, oxygen 12. All right, excellent. Now, is that in fact, this is the empirical formula, and now we need to know, is that the molecular formula? All right, well, we first calculate the empirical molar mass, and when we do that, if you do that carefully, you'll find that the empirical molar mass is the same as the molar mass that was given to us in the problem. So it turns out that this is, in fact, the molecular formula. and congratulations, we just finished the entire problem set. So I hope this was helpful. Hope you're able to work all these problems without too much of my help. We will certainly go over these tomorrow, and hopefully this will help you do great on the test on Friday. All right, thank you very much. Now you can go relax. See you tomorrow.